Today we're going to be sketching cubic graphs. That's graphs of the form y equals ax cubed plus bx squared plus cx plus d. In other words, the highest power of x is 3. Now in this expression, we need to make sure a is not 0, because if a was 0, then it wouldn't be a cubic. So a is not 0, but b might be 0, c might be, d might be. So the basic cubic graph, y equals x cubed, that's what it looks like. The basic cubic graph. Now you need to know the shape of that. Related to that, we have the basic y equals minus x cubed graph on the right hand side. So now the general shape. Both go through the origin and both go up to infinity. So this keeps on going all the way up, and both go down to minus infinity as well. But one starts in the lower left-hand corner and finishes in the top right-hand corner. That's the y equals x cubed graph, whereas the other one, it's the other way around. Now the more general shape is this. So when a is positive, again it starts in the bottom left-hand corner and finishes in the top right-hand corner, but we get a couple of stationary points. Now you don't always get 2 stationary points. As you can see on the basic x cubed graph, there's only one stationary point. In fact, that is a point of inflection. The most number of stationary points we can have is 2. That's if a is positive. Here's the shape if a is negative. Again, at most 2 stationary points. We don't always get 2 stationary points, but maximum will be 2. So notice when a is positive, which covers both of these situations, I'm putting a box around. When a is positive, the graph starts in the bottom left-hand corner and finishes in the top right-hand corner. Whereas when a is negative, it's the other way around. So the graphs of cubic functions can be sketched by first finding where they cross the x-axis. And they will always cross it at least once. Sometimes 3 times. Well, that's the most they can cross it. The most is 3 times. But they will definitely cross at least once. I hope that's obvious from the general shapes on the right hand side. If all cubic graphs go up to positive infinity, which they do, all go up to positive infinity and down to negative infinity, then that means they will definitely cross the x-axis somewhere. Also, all cubic graphs cross the y-axis. They will definitely cross the y-axis. The x cubed term alone determines the general shape of the graph. That's all we need to look at to determine the general shape of the graph. And that was demonstrated on the right hand side. If a is positive, we get this shape. If a is negative, we get the other general shape. To sketch the graph of a function, find the points where the graph intersects the axes. That's the same process whether you're finding or whether you're drawing a cubic graph or a quadratic graph or any type of graph. So find where it crosses the y-axis by making x equal to 0. because that's true anywhere on the y-axis. X is 0 on the whole of the y-axis, and then vice versa. To find where it crosses the x-axis, we solve the equation when y equals 0. Because once again, everywhere on the x-axis, y is 0. Now, remember we are sketching cubics here. So some of them will fully factorize. Not all of them, but some of them will fully factorize. And let me just say x plus p, x plus q, x plus r, possibly a number at the front as well. P, q, and r could be negative. Again, a could be negative as well. The reason I'm mentioning that is the next sentence, really important one. A repeated root is when two of the solutions are equal. For example, when fully factorized, two of the brackets are the same. So this example here, x minus 3 all squared times x plus 2, that could be written as x minus 3 times another x minus 3 times x plus 2. That means the same thing because of what squared means. So that's got a repeated root at x equals 3. What will that look like on the graph? Well, that takes us into the important point to finish off this introduction. When we have a repeated root, this is one of the turning points of a cubic graph. So going back to the example above, x minus 3 times x minus 3 times x plus 2, I know there'll be a turning point on the graph at the point on the x-axis where x equals 3. So when x is 3, I know this graph will have a turning point on the x-axis when x is 3. In fact, this particular graph, if we fully expanded it, we'd get a positive x cubed. So therefore, I know it's this shape. And by looking at the brackets, I can see when y is 0, x is going to be 3 or minus 2. We already knew we had a repeated root when x is 3. So it's this shape going through the x-axis at minus 2 and 3 and 3. When we have a repeated root, it bounces off the x-axis. It's kind of like it goes through the x-axis but immediately turns around and heads back. So it bounces off the x-axis. Hence we get a turning point. It's a very important point to finish off. When we have a repeated root, that gives us one of the turning points on the graph.